Now let's look at the periodic table. The periodic table is a list of all of the elements that we know of and is organized in a way that tells us a lot about the elements. As we go through the year, we'll be using this table to learn lots and lots of different things about all of these elements. This website, ptable.com, is going to be very, very helpful because it is an interactive periodic table, meaning you can click on different things on this table and it explains the different types of information that you can get about the elements. If we look at the table, the first thing you may notice is that the elements are listed in the order of their atomic numbers. Hydrogen is 1, helium is 2, 3, 4, 5, 6, and so on. So that's the first way the periodic table is organized. Some periodic tables have the numbers in each square in a slightly different place, but on this table, they put the atomic number above the element, and on the bottom, under the name, they put the average atomic mass. This may look like the mass number that we used before. And if I round this number, so right now it's 12.01, if I round this to 12, that is my mass number. But why are there decimal places here? It doesn't make sense that if I'm adding up the number of protons and the number of neutrons in a nucleus that I could get anything that has a decimal place in it. I can't have half a proton or a third of a neutron. You just can't break the particles down that way. So where do these decimals come from? And to see where those come from, let's look at how some of your classes may actually be graded. Now that may be a little bit of a jump, but hang on with me for a second. Let's say you're taking a class in which quizzes are worth 50%, homework is worth 30%, and tests are worth 20%. So more of your grade is based on your score on your quizzes than your score on your tests. And at the end of the year in this class, you receive a 73 average on your quizzes, an 85 average on your homework, but a 30 average on your tests. How do you calculate your grade? Well, you might think right away that what the teacher is going to do is do an average, a standard average. So they'll say 73 plus 85 plus 30, divide by all that by 3, and you'll get 62.7% as your final grade. But this is ignoring that each grade is worth a different amount of your total grade. Quizzes should play a much bigger role in your grade than homework or tests. So how do you take this into account? Well, the way you do this is by doing a weighted average. To calculate a weighted average, there are several steps. First, convert the percents to decimals. And to do this, you move the decimal 2 places to the left. Step number 2, multiply the decimals by the corresponding average. So in this case, I would convert the 50% to 0.5 and multiply that by the corresponding average, which is 73. The third step is to add up all of the results. So let's figure out this average. So we take the 50% And the decimal in the 50% is at the end. So to convert a percent to the decimal, we move it 2 places to the left. So we get 0.5. We do that for the other fractions, the other percents, and we get 0.3. And we get 0.2. Now, step number 2 is we multiply the decimals by the corresponding averages. So we have 0.5 times 73, and we do that, we're going to get 36.5. We're going to do that for the 0.3, so 0.3 times 85, and we get 25.5. And then we'll do that for the 0.2, so we'll multiply by 30. And we do that, we end up with 6. And when we add up all those numbers, we end up with an average of 66.345. So you can see that our average, when taking into account that quizzes are worth more than homeworks, which are worth more than tests, our average goes up. It becomes 66 instead of 62, which is a considerable difference. So now let's see how this actually applies to atoms. So let's say I discover a new element, and I call that element medfordium. Now, medfordium comes in several different isotopes, and using various forms of equipment, I'm able to figure out what these mass numbers are. And not only that, I can figure out what the percent abundance of each isotope is. So I know what percent of all the isotopes, all the atoms of medfordium out there are of each mass. So one way I can indicate the mass number is I can write the name of the element and then dash and its mass number. So I discovered that medfordium has a mass number of 250. And this isotope of medfordium happens to account for 45% of all the medfordium out there. I also discover another isotope of medfordium, and this isotope has a mass number of 254. The percent abundance of this isotope is 25%. The remaining medfordium in the universe has a mass number of 251. And this would account for 30% of all the medfordium in the universe. So, knowing this, and knowing that each isotope of medfordium occurs in a different percent abundance, I need to calculate an average. Now, would it make sense to calculate a straight average, adding up the masses and dividing by 3, because there are unequal amounts of each isotope in the universe. So we need to use the same method we did for the grades in order to calculate the average atomic mass. So the first thing I do is convert the percent to a decimal. So 45% is the same as 0.45 as a decimal. I then multiply that percent by the mass number. So the isotope that has a 45% abundance has a mass number of 250. When I do this math out, I get an answer of 112.5. Now for the next isotope, I just repeat the process. So I convert the 25% to a decimal, 0.25, multiply by the corresponding mass number, which is 254, and the answer I get is 63.5. And for the last one, 30% becomes 0.3 times the corresponding mass number, which is 251, and doing that out, I get 75.3. And the last step, I add all these numbers together. So 112.5 plus 63.5 plus 75.3. And when I add those all together, I get a final average atomic mass of 251.3 AMU. AMU stands for Atomic Mass Unit. And this is going to be our unit, AMU, whenever we have average atomic mass. And this is what's listed on the periodic table. One final way of looking at this process is saying that, well, 45% really means that if I had 100 medfordium atoms, 45 of them would have a mass of 250, 25 would have a mass of 254, and 30 would have a mass of 251. So if I really wanted to, I could add up 250 45 times. I could then add that to 254 25 times, add that to 251 30 times, divide all of that by the total number of atoms, which would be 100, and I would actually get the same thing. And that's what this math is doing.